This is Chapter 9, Section 9-1. This is recording number 2. Okay, folks, so here's the outline of the chapter. As you can see, we have the 5 different sections here. We're going to be talking about means, proportions, and variances, just like we did in Chapter 8. And this is why I have several times tried to explain the distinction between Chapter 8 and Chapter 9, because they sound so similar, and we use the same distributions for the tests in both Chapter 8 and in Chapter 9. It's very confusing based on my experience, so I hope I haven't believed. Okay, so for the means, we have 3 sections, right? We have testing between the two means, the two sample means. We're going to use the z-test, we're going to use the t-test, and then we also have another one where we're going to use the t-test. So it's hard to keep these straight. So let me make a recommendation to you. I want you to look at this page. Okay, this is page 540 of the 10th edition. Obviously, it's in the 9th edition as well, but I can't give you the page number. I've always recommended that you read the summary first. Now, I don't think it's worth class time for me to just sit here and read this to you, but my strong suggestion is that you read it, and I hope you do. Okay, it kind of gives you the overview. You will not understand it all, but at least you'll have an idea of what's going on. Well, here are the formulas, and as you can see, we're going to have a z-test if we're comparing two means, independent population, and the sigma. So that sounds very similar to what we did in Chapter 8. This is talking about confidence intervals. Now here we have the t-test, is if we have independent samples and we know the variance. No, I'm sorry, I beg your pardon. This is for the t-test, is for comparing the two means, but they have to be independent samples, and we also have to have another requirement of the two samples, the variances are not equal, and we have to have sigma 1 and sigma 2 are unknown. So just like before, if we know the population variances, then we can use the z-test. If we don't know the population variances, but we have these samples, then we use the t-test. I hope that makes sense to you. So that's just like we did in Chapter 8. So there's another condition, though, and that is right here. If we have dependent samples, and we'll define that in a while, dependent samples, we can still do a comparison, and we still use the t-test. So we're going to use the t-test in 2 different ways. We're going to use it for independent samples, and we're going to use the t-test for dependent samples. Okay, so let me get back to my original, let me get back to the text. Okay, so in section 9-1, we are talking about the differences between two means. You take a sample from the population, and you take another sample from the population, and you compare those two samples, okay? And in section 9-1, we always assume that we know the variances, or the variance, I should say. We know the variance of the original population. If you don't know the variance of the original population, then we're not going to use section 9-1. We're going to use section 9-2. Okay, so here's the scenario that the author's talking about. Researcher wants to know if there's a difference in the average age of nursing students who enroll in a nursing program at community college versus who enroll in a program at a university. Okay, so here we're not concerned about the average age of all nursing students. We're not interested in the average age. We're interested in comparing the means of the two groups. Okay, that's my question. Okay, not the most exciting question in the world, right? Okay, so that example doesn't seem to be very exciting. Let's look back at the introduction here, which hopefully you've read. it's worth spending a few moments on this. And what he's saying here is that, the basic concepts were explained in chapter 8. What we're going to do now is really the same thing. It's the same concept. We're going to be creating a null hypothesis. We're going to be creating a alternative hypothesis. We're going to decide what is the test value, comparing that to a critical value. Everything is exactly the same in chapter 9. So this chapter will go quite a bit faster, okay? But then he's talking here, here's the distinction. In chapter 9, we're going to compare the two sample means. And the way we normally explain this is we talk about experimental and control groups. So we have for example, the average lifetime of two different brands of bus tires. We take a look at those two, okay? So in a situation like that, the experimental and control groups, maybe that's not such a great terminology to use if you're just talking about two different brands. So you got to keep in mind that, that sometimes the language gets in your way there. Maybe a better example here is the one that I talked about before, and that's this new medication. I believe it was pronounced remdesivir, whether that's effective in treating the COVID disease. In any case, this language, experimental and control groups, sometimes that makes a lot of sense, sometimes it doesn't. What it boils down to is what we're really trying to just get to, the point of this whole story is that you have two samples and you are comparing the means. You want to decide if the two means have any statistically significant difference. So here's what he's talking about here. The comparison of two means, the same basic steps are done as before. You have the z-test and the t-test. However, in the t-test, there are two different scenarios. You can use the t-test if the samples are independent, but you can also use the t-test if the samples are dependent. So that's going to be sections 9.2 and 9.3. 9.2 is the t-test when they're when they're independent, and the 9.3 is when the samples are dependent, okay? And then in section 9.4, we're going to talk about the z-test. And then in section 9.5, we're going to talk about the variances. Okay, so we're going to compare. Here's the example that we started with, the nursing program. Not very exciting, but it's just a metaphor. We're going to compare the mean of the two groups. So if you don't like this example, think of comparing the medications, okay? All right. The hypothesis would be that the two samples come from the same population, all right? That's the null hypothesis, that mu1 is equal to mu2. The alternative hypothesis is that the two samples represent populations who have different mu's. There's a mu1 and there's a mu2, and they are not equal. Okay, so can you see that here? It's so important to be able to clearly articulate what the random variable is. The random variable is the age of the beginning nursing students at either the community college or at the university. So the first group here, the first population, so to speak, is community college, average age, or I'm sorry, I should say the age. The age is a random variable. The mu is the mean of the random variable age. Okay, I hope I got that straight. Okay, here's an important concept here. If you're saying that the null hypothesis is that mu1 equals mu2, another way of saying that is that the null hypothesis says that mu1 subtract mu2 is equal to 0. Now, can you see that? Let's say you think that the average age is 22. So 22 is equal to 22. Well, if 22 is equal to 22, 22 subtract 22 is equal to 0, right? And then similar remarks apply here. And we're gonna use that here in just a minute in our formula. Okay. Now, what do we mean if they're independent? When we say that they're independent, what we're saying is that the subjects that are selected for their first sample in no way influence the way that the subjects are selected in the second example. If you take 50 people and you randomly divide them into two groups of 25 people each, because you want to test this new drug, okay, well, the samples are independent, right? But they're going to be dependent if the people that you picked in the first group somehow influences the people that are selected in the second group. So they're using the example of the right foot and the left foot. How about husband and wives? Okay. Or how about, husband and wives is probably as good an example as any. Another one might be if the random variable is your performance on a test before and after you took a review class. So let's say you were comparing in group number 1, you're taking the test, you get a score. Group number, and then afterwards you take the test again, but in the meantime you've taken a review course. So the people that are in the second group are influenced by the people that are in the first group, and the performance is going to be different because people, tend to do better before and after they take the review class. Okay, so we'll see some examples, but the bottom line is random means random. It means that there's no, or independent, I should say. Independent means independent. There's no influence on the second group at all based on what happens in the first group or who is selected in the first group. Okay, so here's the requirements. So remember we're in 9.1. We're going to be comparing the means. Here's the requirements. Both samples are random. They must be independent. Okay, and then the standard deviations of both populations must be known. If you don't know them, you don't quit. What you do is you use the t-test, which is in section 9-2. So this is very similar to what we've done before. If you know the standard deviation, then you can use the z-test. Okay, so now, if the sample sizes are less than 30, if you have a small sample size, then it must be true, one of the requirements is that the population of random variables must be normally or at least approximately normally distributed. Now other textbooks will say, well, they have to be normal or they have to be at least symmetric. So I guess if they're symmetric, that at least some authors say that that's a good enough satisfaction of the requirement. Okay. Okay. So let's go ahead and end this video, because I want to get into this discussion of what we're really trying to do and why this works. So that'll be the end of this video.